The first speaker is Sharon Terry, who is president and CEO of Genetic Alliance. It's a network of about 10,000 organizations. About 1,200 are disease advocacy organizations. She's the founding CEO of PXE International, a research advocacy for those with the genetic condition pseudoxanthoma elasticum, which is a disease that affects Terry's 2 adult children. So she's a co-discoverer of the gene that's associated with PXE, has a patent for ABCC6. She's developed a diagnostic test, conducted clinical trials. She's done it all and has a very, very important story to tell us. So Sharon, tell us about health advocates as scientists, progress, and how we can all participate.
Thanks very much for having me here. I'm always delighted and always say yes to Marianne, even when it means skipping out of IOM board meetings and other events. So I'm sorry that I couldn't be with you yesterday or the rest of today, but I'm delighted to come for this part. So I am going to talk to you today about women health advocates and as scientists. Most of the health advocates that I work with are women, so that's kind of easy to do. There are certainly some men as well, so I'm being a tad bit facetious there. But really looking at what does it mean when a lay person comes into a community essentially like yours of scientists who have done amazing things through the means that you have done. So as Rita said in my introduction, my 2 children were diagnosed actually the Christmas Eve 1994, so it's 20 years this Christmas that they were diagnosed with pseudoxanthoma elasticum, and I was a college chaplain. I'm a former Roman Catholic nun. Have really proud I never took a single science course in high school because I went to a Catholic high school where they didn't have any requirements. Lots of kind of hippie 1970s stuff. And so when my children were diagnosed, I just thought, abracadabra, somebody will do whatever you need to do. Really devastating, though. My kids will tell you it's the best Christmas of their lives because we bought them every toy they wanted, and they are now they're now 27. My daughter turned this week, and 25. My son, who got married this summer, and this is a picture of them at the wedding. And they're both very happy. They would say they're both very healthy. They show all the signs of progression toward things like legal blindness when they're 30 or 40. Intermittent claudication, cardiovascular disease, gastrointestinal issues, etc. But they would tell you that this is what life is. It's filled with all sorts of things, and this is an important part of their lives. So that Christmas, again, we kind of waited a couple days because we thought somebody will tell us what you do when you have pseudoxanthoma elasticum, aside from saying PXE means never having to say pseudoxanthoma elasticum. So we waited a couple days and nobody could tell us anything, and we started to, you remember this is sort of early internet days. PubMed was called what was it called, Grateful Med, and it was all DOS, kind of looking characters, and we tried to look into it and we really couldn't. So we lived in Worcester, Massachusetts, and we went to the newly constructed medical library and we Xeroxed 400 articles, and we brought them home, and we realized we couldn't read a word of any of them. My husband went to high school and learned to draft and was a drafting engineer for the Boston biomedical facilities and stuff. So neither one of us any science background. We then went back to bookstores and libraries and bought Stedmans and bought all sorts of stuff, just saying we got to figure out what these articles are saying to us. So we realized really quickly, several days after Christmas, that we were going to have to actually create a commodity, and the commodity was going to have to do a lot of things. It was going to have to organize a community, leverage and offer funding for research, coordinate research studies, coordinate communication, and focus on clinical significance, really early what now is called PCOR, patient-centered outcomes. And we realized that because even though we didn't understand any of those 400 articles, we could see that there were no patterns. There didn't seem to be any logic. There were case study after case study after case study. It's a very rare disease, 1 in 100,000 people. We didn't know that medicine didn't have all the answers. And so we began to learn that. And we put together a whole kind of platform to do work. The first thing we did and I'm not going to spend a lot of time on my story because I actually want to tell you several stories. But the first thing we did was say, wow, all these scientists seem to be not working together, which was also absolutely astounding to us. We couldn't imagine that if you're working on human health, you don't all say all for one and one for all. So the 3 or 4 days after Christmas, 2 guys came from Harvard University, took our kids' blood and our blood without any consent, by the way, in those days, saying, we're going to find the gene for this disease and this is fabulous, you have 2 kids. And we're like, oh, okay, this is really exciting. We didn't, as my husband said, we didn't know a gene from a hubcap, so whatever, go get that gene out of that blood. And then about 3 days later, we got a phone call from Mount Sinai and 2 researchers saying, we really want to find that gene, so we'd love to come and take your kid's blood. And we said, oh, great, well, the guys up the street at Harvard took the blood, so go get the blood from them. And they said, are you kidding? We're competing with them. So we right away said, oh, something's really different here and, not coordinated. So we basically then established about 2 weeks later a blood and tissue bank. We said, we're going to own the blood and tissue. We're going to control the resource because one of the conditions of participating in getting this blood and tissue is going to be coming together and sharing results, and we'll embargo the data and all the things we need to do, but we're going to coordinate that kind of sharing. So at the same time we moved to Sharon, Massachusetts, and started to go to the Harvard Library, tailgating students into the library because it cost $25 every time we went in. And we started to do more and more research there on the disease in terms of reading articles, etc. But we also started to talk to scientists there and say, hey, can we wash test tubes? We didn't realize people weren't washing test tubes anymore. But what can we do to kind of help this research along? And so they said, yeah, you can come in, maybe in the evening. So we started to go in at 10 o'clock at night and come home at 4 in the morning. Had a fabulous across the street neighbor who took care of the kids. She was a nurse in the nurse's study, so she totally got that research is really important. She turns 92 next week. Really, really enabling for us. Anyway, we went to the lab every night for a year. My husband went much more than I, and we actually discovered the gene ourselves. We ran gels, we scored them, we put the data then in Excel spreadsheets. My husband's dyslexic, so he could see the pattern and he could see the locus, and he figured out there are 5 genes in this locus. We now need to hone in on which one. The researchers all wanted to go toward the ones no one had ever discovered. We wanted to say, let's be agnostic to whether they're discovered or not and just get the gene for this condition. So we found ABCC6, which turned out to put us in a whole other field. We at that point had all been with all the elastic tissue, connective tissue, matrix biology guys and women, and now we were in the ABC family, cystic fibrosis, a transporter, membrane transport protein, and lots of confusion around what it did. And that was 1999, and we didn't until this summer figure out what that membrane transport protein was doing. So we established a biobank, established a clinical test that could be used and licensed it for $1 because we owned the gene, because we patented it. We're the only lay people to do that. And of course, it was thrown out in the Supreme Court decision. That's fabulous, right? And we're happy about that. Of course, we did patent stack, and so we have the patent for the diagnostic, et cetera. But we licensed it for $1 with the only reason for us licensing it is to bring in the data back to a central repository, which is the system that we run. We also had going on now, and then the other thing my husband loves to point out is that I had 2 back-to-back papers in Nature Genetics in 1999 with my master's in religious studies. And then now we're doing drug screening. And some of our drugs are kind of funny. Magnesium turns out to at least ameliorate the disease in mice, and so we're looking at that. The summer's finding looks like bisphosphonates might have some mitigating effect because it looks like pyrophosphates are too low in peripheral blood, etc. So this project plan here, my husband put together about a month after the kids were diagnosed, and it looks a lot like a plumbing diagram because he was a sprinkler engineer. But it's really served us very well, and other diseases have used it, in fact, and we have essentially almost every single block on this pathway have we done some work in over these 20 years. We published this model in 2007. Again, Nature Reviews Genetics this time, essentially to help other disease groups do this, because one of the things we realized about 2 months into it was that it was silly. Again, the system just wasn't there for everybody to do this, and we should have walked into a system rather than having to invent all this stuff. As my kids said, ovaries next to the ice cream was not fun growing up. And so, you know, for example, having a bona fide biobank and having an IRB and having all that stuff we had to learn. So what we did is we started to put systems together that lots of groups could use, and began to work with Genetic Alliance, which I'm president and CEO of the last 12 years or so, in order to give people a platform to do the same kind of thing and do it much, much easier. So switching to some of those other stories, this is, some people actually know this foundation, the Progeria Research Foundation, because Sam, who's in this picture, just died this year, at 17 years old. Hutchinson-Gilford progeria is a rapidly aging disease. But the point of this story, and I'm going to go through just a couple of these, is again, really forceful women who were essentially lay people. Audrey Gordon in this picture, she's a former lawyer. She gave up her practice in the Boston area to take care of the foundation that they founded essentially a couple of years after us and on the backs of what we had done. Progeria is extremely rare. I think they found maybe 120 people worldwide with it, and people meaning children. Most people die around really aged 13 or 14. They've been able to extend life slightly already, but as you can see all over the world, many languages. So they're really dealing with every language you can imagine. And doing clinical trials means bringing these children who are very fragile already into the United States and helping them through the trial, which they run at Boston Children's Hospital. Their history, again, I'm not going to go over every detail of each of these, but you can see again a really strong path, a very quick one from 1999 to 2014. They've extended life, which is really fabulous and amazing. And again, lots of just lay people working on this condition. His two parents did have medical backgrounds. His mom had just finished med school when he was born with progeria. So she did have a medical background, but still not all the material transfer kinds of arrangements and the business arrangements and even the coordinating research isn't something I think that scientists learn as they go through various programs to get their PhD or their MD. Lots of coordination with many collaborative groups. And I think the other really remarkable thing during this time was, as I said in the beginning, lots of competition in 1994, 5, 6, 7. Still competition today, absolutely. But what we're finding is, I think in the understanding that if we share what we can call pre-competitive data, what we can maybe even go all the way up to phase 2B with, some people are looking at that as a kind of boundary line, then there's a lot more sharing, a lot more happens more quickly, and all of that accelerates the research much faster. So what we're finding also is that if we're at the center as lay people with some skin in the game, because I would say we're not without conflict, just like scientists have conflicts, we do too. We actually have the biggest one in the room, but then it's an obvious one, and we can coordinate everyone's activity together. They also run lots and lots of pieces of their program in terms of all the way to clinical trials, but also support for individuals. 54 projects. They've raised $6 million. So when disease advocacy groups come to me and say, I can't raise money because I have a rare disease, I say, well, this is a fabulous example of if you put your heart and soul into it, and certainly they've been very compelling. You know, they've gotten all the sports teams in Boston support them. They've gotten fairly famous people, Ted Danson and others, really come out and support them. And they've done a lot of work with regard to scientific conferences, which most of us do. This is a slide I thought that you would all be interested in. The publications, once they found the gene, skyrocketed, and as they get closer to translational science, there's more activity. And again, I think we've seen a huge push toward translational science with formations of things like NCATs and others, a real blossoming of journals in this area, and the journals have really understood what it means to explain that translational science. And then also big data. Big data starts to be really important, and again, we've seen Liebert and others be really responsive to what's going to happen with all this data and how do we make quality sense out of it. Big data for big data's sake, it's not going to really move the needle. They have a lot of drugs in experimental trials right now. They pushed really hard to move them very fast. They've done some really novel things, and I'll talk about FDA in a second with another group, but they've also had a lot of influence on FDA. Lots of publications about those trials. Another group that's done a phenomenal job is Parent Project Muscular Dystrophy, PPMD. PPMD is especially dedicated to just Duchenne muscular dystrophy, but also includes others. But Duchenne is that muscular dystrophy that affects boys, and they generally pass away somewhere around 20 21 years old. The woman who started it, Pat Furlong, had 2 sons. They died when they were 15 and 16, Christopher and Patrick. And she remarkably, lots of times when people's children die, they then kind of move away from the foundation that they've begun. She remarkably has stayed the course in a really phenomenal way and done amazing things. They have a lot of drugs in clinical trials, and a lot of this is due simply to her persistence in terms of visiting companies, asking them to get involved. Again, people look for a very logical way. They say, well, companies are not going to be interested in rare diseases because of the issues around trying to market to such a small population, etc. Certainly the Orphan Drug Act has helped hugely, but there are 7,000 rare diseases and only 300 are treated. It still needs the advocacy of women like this to get out there and say, we need to be changing how this is done. We have also seen a huge uptick in interest in rare diseases. And in fact, one of my comments lately is there are more rare disease meetings than there are rare diseases now. And that starts to get some kind of negative connotations because of the competition now in that field. But in any case, I think the advocacy of women like Pat has been phenomenal. And I'm not going to go through this, but it's a really, really remarkable thing because she went to FDA and said, you know, you really are measuring the wrong stuff. We're having all these clinical trials, but endpoints in these trials are super important, as we all know. They were using traditional things like the 6-minute walk test, and drugs were failing one after another, but then they would go back and look at a surrogate marker like muscle mass and see, oh, you know, that actually looks like there was some improvement. And what the boys reported, so this is a really terrific early patient-reported outcomes story, the boys reported, yeah, you know, I can't walk because now I'm in a wheelchair. But much more important to me is I seem to be able to be typing and Facebooking and instant messaging faster than my friends who are not on the drug. This is when the trial's over and it's unblinded. And to the boys, the biomarker should have been, can I still communicate with my fingers? So she got FDA to look at, can we look at different kinds of markers? Can we understand biomarkers in a different way? Can we start to look at what's important for the community? And put together these pillars like patient-centered drug development that truly is, and not just lip service, treatment preferences, potential treatments, and benefit risks characteristics. Looked at what does it mean to make this community-centered. The community's begun to be very preyed upon. Lots of people want to swoop into these communities. I don't know if you all heard the cystic fibrosis drug Kalydeco, which was created by the company Vertex, came out this summer. Kalydeco's price point is $350,000 a year per person. It's a completely unsustainable model, but you can imagine that lots of other companies have now said, I want to have the next Kalydeco. I only need, 50 people on that drug, and I'm going to be making buckets of money for a lot of years. The Cystic Fibrosis Foundation just sold the royalties to futures in a futures market with capital investors for $3.3 billion. Now, lots of people said, that is fabulous, an advocacy group getting that kind of money and putting it back into the research enterprise. We have to ask, is that a sustainable economy such that a futures expert would bet on the profits from this drug being so high that it's worth $3.3 billion. So lots of questions in there, and what Pat has been trying to do is say, we got to calm it down, we got to get it to a place where it makes more sense economically, as well as still has an incentive for the company, because we don't want to disincentivize the companies by any means. So lots of things that she worked on in community-centered things. And then treatment preferences. She studied these treatment preferences. She did a experimental design that used an orthogonal array looking at 18 different treatment attributes so that she could understand what did people really want. They were across things like this, and these rose to the top. So again, none of this is specifically interesting, but generally interesting in that she was able to work through this fairly long, year-long study and get the FDA really to understand it and to put out a guidance based on the work she did. So again, layperson bringing forward and then some conclusions, understanding what things were important, what kind of risk could the individuals with the conditions accept. So this brings me to sort of back to Genetic Alliance and some of the things that we're doing. So Genetic Alliance in 2003, I built a common cross-condition registry in biobank. Again, the idea being the next mom that called me with a kid who was diagnosed with something shouldn't have to go through figuring out where to put the samples, etc. Another fabulous part of our story is that we did put our samples after we took them out of the freezer with our friends at Harvard, figuring that their backup systems and all this stuff was great. We had phenomenal help at the time from NHGRI and from Elizabeth Thompson, who was there helping with this, the ethical, legal, and social issues. Fabulous. It came a day when we wanted to work with more than Harvard, and we went to go get some samples to ship to the University of Hawaii, and the researcher at Harvard locked the freezer and said, "You're not touching this stuff, it's mine." And we said, wait a minute, there's 120 samples in there, and they are samples that we collected from all over the world, and we need to now share them because we have somebody else interested in the research. He said no. So we muddled and muddled about what to do. Finally decided we would threaten to talk to the Boston Globe. We weren't going to, but we threatened. And the next day, the Harvard called us and said, you can come and get all your samples and take them out. So we went to get them, feeling like, wow, it's really bad that this went sour. We used to have these people over for our kids' parties. We went on vacation with them, over just the kind of quantity of the substance. So we came, and they were sitting in the hallway thawed. They had been there like 24 hours, and half of them were missing. They kept half frozen. So we took our stuff and went and banked them actually at a friend who was studying E. coli, because I figured he's not going to touch them. He has no interest in them. But the moral of the story for us was, sort of back to my nun days, I said, if Jesus wanted to share samples with me, I'd have him sign a contract. This is like, we are definitely going to have this all very, very well codified. And certainly, again, Claire Driscoll at the National Human Genome Research Institute helped us, and others put together material transfer agreements and all the things that we needed. So we thought, why should everybody go through that? Whether or not they would have such an extremely awful experience as ours. And actually, we've heard that over and over since then. We decided to put together this blood and tissue bank so that lots of groups could bank, and a registry.
That a minimum number of lines are connected to this conference. Do you want to continue your meeting?
What do you think? Okay. All right. Good. Yeah, there we go. Get a contract. Yeah. So we decided that we really need to do this in a much more systematic way, and the biobanking side has been somewhat.
Now he's doing Morse code.
Yeah, that's that help signal, right? Okay, thanks. No worries. So what, and while I was getting the slides back up, so we decided that we needed to do that in a more systematic way, and we have since 2003 run a blood and tissue bank for anybody. We have different vendors, different times for different things. We run as a co-op, so if a group comes in and says to us, oh, well, we need more than fibroblasts, we also need lymphoblasts, we then contract with somebody else to grow us good lymphoblasts. We're able to negotiate pretty inexpensive storage, etc., because of our nonprofit status, and so that's been very helpful. We also put together a suite of things to teach people how to do this. So this is a toolbox on biobank.org. I actually own that URL. I was so proud of that. That and phenotype.org we bought in the middle of the night, like a week after our kids were diagnosed. We put together all sorts of resources here, and lots of these point to other people, not us. So they point to NIH, they point to FDA, they point to Faster Cures, they point to other places that are doing really great work in these areas. This is to say now, we took this registry concept and kind of even blew it up bigger. This past year, the PCORI, which is the Patient-Centered Outcomes Research Institute, which is about $1.7 billion of US money, 1 to 2% of the CMS budget, the Medicare, Medicaid budget goes to it. And the point of it is to do patient-centered outcomes research. And the point of PCORnet is to build a national clinical research network. And so there was a very big competition, about 600 groups competed, and 18 were chosen to be patient-powered research networks, PPRNs, and one of them is ours right here, this Genetic Alliance one. And what I proposed in it was simply to take an example of 10 disease groups. We did a competition among the disease groups to see who could join us, and bring these disease groups along on a registry platform that I'll show you right now that I think has been really successful and continues to grow. PCORI is really fast. I'm now on the executive committee for PCORI and helping to coordinate these PPRN, and it's really been fascinating to see what we can do together. Again, this age of cooperation, collaboration that I think we're in finally has some meaning, and we're putting some rubber to the road and talking about what can we share, what can we work on together. So we started with the premise that while we, the people with diseases, are happy to share everything all the time, we know that's not true about the public, and different publics have different sensitivities. And essentially, we like to use the example of Michael J. Fox, when he was first diagnosed, was way down there in the red. He didn't want anybody to know. He wanted to just have movies and TV shows and everything else. Now Michael J. Fox is all the way at the end of this green, saying share my data all the time, everywhere, tell everybody. He has a foundation. He wants people to support it, and he wants to find a treatment for Parkinson's. But we know that most people wind up somewhere in the middle of this, and this is work by Ellen Weston for the IOM. And we also know there's lots of models along this line about how to do this. So there's the perfectly open models like George Church's Personal Genome Project, where everyone, and I'm part of that project, we essentially sign a form saying it's possible you'll be arrested and put in jail based on somebody finding your DNA and finding a connection to you. Little extreme kind of consent form. And then there's all the way down the end that's effectively an opt-out model that says, no, I don't want to share with anybody anytime, and I want to be out. And then most people fall in the middle. Most people are pretty open about their information, but what we've seen, and I didn't bring the slides for all the data, but Pew Charitable Trusts and Robert Wood Johnson Foundation and lots of work by independent researchers has shown, yeah, well, people really want to be asked, and then they're fine. And the example I like to use is if I went to any of your houses right now and rode off on your bicycle without telling you, you would call the police and report it stolen. If I went and asked you, could I borrow your bicycle? You'd say, sure, use it as long as you like. So all we want to do is be asked, and usually we're going to say yes, but we should also be allowed to say yes or no or not. And the other thing we're really concerned about is underserved and marginalized community and group harm that is coming from certain studies. So Native American and Alaskan Natives have been studied, and declarations have been made. There's a propensity toward alcoholism, there's a propensity toward obesity, etc., not taking into account a lot of other issues. And so we're trying to figure out ways for individuals and for communities to make those decisions themselves. We're also making this easy to respond to in an app form, and I'll show a little bit more about that. So the system essentially looks like this, and I'm not going to go into great detail, but this middle part is our registry system. And it's unique in the sense that the contact information and the health information are together in two separate databases, directed by these privacy directives, this other database right here, which then creates a virtual database. So anytime this system is queried by that orange block, the data query facility, so that could be a researcher from far away, it could be part of PCORnet, it could be part of the CTSAs, whatever, that query queries the database, and the privacy directives tell it what can go into this permitted information. This information comes in from a consumer portal, and I'll talk about that in a second, curated survey data, EHR data, and genomic data, and then a researcher can Google this data, in the verb sense, on the other end to get the data out. So lots of people have said to us, well, that's great, but it's pretty complicated. Again, we're aiming toward the average person. We're aiming toward those people, first the people who have had a diagnosis or a child with a diagnosis, and then eventually the general public. We've given them guides, and the guides come from the community. So in this case, you're looking at Joubert syndrome, a dad of a kid with Joubert, a board member who's also a parent, and then one of the people, professor at the University of Washington working on it. And then also you can create your preferences manually as well. These guides are telling you how do they feel about privacy. So you can see Nicole here has slightly higher privacy concerns than Stephen does. Well, actually, no, sorry, Stephen has slightly higher than she does, and Daniel's in the middle. We get people at different ends of the spectrum, and they share their feelings, and they share high, medium, and low preferences. So each of the 3 guides are giving 3 different sets of preferences. And what people do is they select a guide that they feel looks like them or sounds like them. Right now we're only allowing 3, believing that people will get even more confused if we give many more, but the system can certainly take more. So what does it mean that they are giving recommendations? So they're giving recommendations over all this spectrum. And again, this matrix is fairly complicated, but it's already set up when they come in, and they can accept it, which is continue to survey down there in the bottom. About 80% just accept the guide settings. What are you accepting? Well, the guides are asking who can access this information from support groups, from medical researchers, or from data analysis platforms. And in the columns you see who can discover and view my anonymous information, who can export and use my anonymous information, who can contact me, view and use my personal information. And essentially what this is saying is, unlike a lot of systems that say, well, anonymous information, de-identified information, and I'm using those words interchangeably, which we should never do, because they mean different things, or limited data set, blah, blah, blah. I'm trying to make this as palatable for the public, and they can click the box and read all that. Anyway, that data is usually shared easily and freely. And what we've discovered is, for example, in the UK, when care.data shared all the NHS records, the people went up in arms and they shut the project down. We're not going to do that. We're going to say, even your anonymous information, you can allow, you can say ask me, or you can deny. And you can come back and change these. So this is called granular and dynamic privacy settings. What we're noticing is about 85% of people say allow, 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 allow. 10% say ask me in some of these categories, and only 5% are saying deny for some of the categories. So people often push back at me, especially scientists, and say 2 things. 1, you're skewing the data. There's going to be people saying no. I'm saying if 4% of Americans are involved in clinical trials, if I could get it to 8%, 15%, this would be really terrific anyway to start with. And the second is if people can self-select out even further, so sometimes they're not allowing you to contact them, then this will also further damage sort of the research projects. What we're finding, again, is most people are saying yes, and most people, when they're asked in the Ask Me category, say yes when they're asked, because they feel a connection and need the context. They can't just do this with no context. And then again, I'll just go quickly through this. We are collecting all these different areas. You see medical records is grayed out. It's a really difficult area, as most of you know. Electronic health records are not, EPIC is not EPIC is not EPIC, Cerner is not Cerner is not Cerner. We're trying to figure out which kind of conduits we'll use to kind of be that electricity adapter to get different kinds of records in. We're adding each of these so that the physician can add data, the lab can add data, and so on, and then the opportunity to set automated reminders and also look at things longitudinally in a chart form. The individuals themselves are able to log into this to see who's looked at their record, because there's an activity log. And then the other good thing about this is it looks like where it lives. So this is a sickle cell project we did with the FDA. FDA wanted to know what people would accept in terms of risk and benefit balance for drug development in sickle cell. This is Maddie from the Sickle Cell Foundation. This is their website. These are their colors. This is a free the data, where we get more toward policy work. This was to get the variation, Myriad lost the patent, but it keeps the database with all the information in it for variation. We're trying to get that variation into the public domain. This is a public effort where women are uploading their BRCA reports, again, deciding who will see it, just ClinVar at NIH, or maybe more people. What phenotypic data are they going to put with it? And again, looks like the free the data people. And last slide, so in addition to all this sort of nuts and bolts work in health advocacy, we think it's really important that we also foray into the policy world. So the talk would be health advocates as policy wonks or policy people. Again, we don't have any background in this, and I helped to lead the coalition of 500 groups that passed the Genetic Information Non-Discrimination Act, and went to Capitol Hill as a complete neophyte, a person from Massachusetts who didn't know really anything about the political process. I had to read that how a bill becomes a law thing, But I think there's a kind of freshness when somebody's not a professional lobbyist, and we've had a lot of success. So we've led a whole host of efforts. Again, I'm not going to read all these, but essentially ways to get involved in helping the policy further the translational science efforts that we all want to see, Right now, we're working on the OHRP guidance for standard of care research, working on the laboratory developed test guidance for the FDA, things like that, and rallying the troops to actually answer those questions in a way that makes sense for people that are really participant-centric. And there's my contact information. Thank you. Right on the button. Yes.
Sharon, how big a staff do you have? You do such phenomenal work.
But thank you. Thank you. So I had a staff of 2 when I came, and a budget of $400,000 about 11 years ago. We swelled to about 25 about 2 years ago with a budget of $4.4 million. And then Barack Obama did that fabulous State of the Union address where he said, "I will cut federal spending," and he did. So we lost all of our federal grants except one and shrunk to about 10. And I'm happy to say we are now at about 15. We'll be 18 in January. Because of moving what I said from a federal grant model to a prize model. I won about $500,000 in prizes for this platform, which was good money. And now I have the PCORI grant. I will announce on Monday a Robert Wood Johnson Foundation grant for this platform. And then we also just received a grant from the FDA and pharma. So we're growing again. But I'm very mindful of we're going to have to keep a diversified base for our support. I mean, you remember I came to you about 2 years ago and said, we may be out of business, but we're solid again.
That's remarkable. And you go before Congress quite frequently, is that?
Yes, yeah. So we've worked a lot with Congress. I mean, we've had some fabulous years when lots of champions were in there. It's tough years now because there aren't the champions there were. But things like the 21st Century Cures Act with Upton look like they might be somewhat successful, and we're again in conversations there. And the Newborn Screening Saves Lives Act just got passed last week by the Senate. They snuck a little provision in that said now the states can't keep blood spots unless they consent every single parent, which is phenomenal. It's a huge change. But that law gives us about $800,000 to run the nation's newborn screening clearinghouse, which we've been doing for about 5 years. So yes, we do keep our policy work together. I'd like to do much more of that. I think that's really, Tom Frieden has that pyramid where he says your real work should be in policy because that's what changes the nation. And I'd love to be there, but there's not a lot of support for lay people to be involved in policy. There's lots of support for lobbyists and for policy firms, but not for lay people.
That's spectacular. And first of all, I think that it makes it clear that when we talk about when you make your career choices, how knowledgeable you are about where you want to go. I mean, your path has been spectacular. I was wondering, one of the things that we as scientists do is always, not only are we going to cure a disease, but we're going to learn from that disease how to prevent something else. And so the progeria studies, for example, have been very much in terms of aging. Now you would like to turn it on?
That's what he says.
Okay, what?
I don't know what
So, no, I don't think that did it.
No.
Either.
I'm not.
On. Let's slide this up. Let's see if
That's
there's a
what it
slide.
wants.
Yeah, hello? No?
We can hear you. Just
I think there's no problem.
Yeah, it's okay.
So anyway, just the question of how much do you take your approach and move it on again to bringing it back into the lab and perhaps other impacts of the work?
Yeah, that's really a terrific question. So I think 2 answers to that. One is we've stayed very much in touch with and actually kind of grown in our cooperation with professional societies. And worked a lot with them with trainees, so go to the American Society of Human Genetics, American College of Medical Genetics, American Academy of Ophthalmology, et cetera, and work with the trainees who come in and talk to them about kind of broadening how they see science, which there's a real hunger for that again, as somebody, I forgot the cute thing they said yesterday, but essentially the idea that, you get your first R01, I guess they said it's late onset R01 now, that it's really in the 40s, and so I think younger scientists are looking for other things, other ways they can contribute and be live. The other way is to sort of take it back to the advocacy community itself and ask them to become sort of soldiers to go forward and work with the scientists. And so I think we've created fabulous collaborations, and we've really said there should be no us and them. That's the worst thing. It's a we, and we are all in it, and we have to take care of different sides of it, but if we work together, it's really, really much better. And then very formally, I've done work. So I co-chaired the Institute of Medicine Committee for the CTSA review and looked at, what do trainees need? What do we need in terms of sharing and collaboration? What do we need in terms of community engagement? And I think that was also, in fact, NIH is implementing that report, and that's quite remarkable.
If I might say, this is a collaborative model, something
Right.
that women do with the CTSA.
Yeah, and I'm trying, there is 3 men in the room, yeah? I'm trying not to be
Some tall white men too.
I'm trying not to be leaning too far, but I do think I have discovered obviously that moms and women do bring this piece into it that isn't there before, because I even see my husband negotiates things very differently than I do, and if we need to get collaboration, I'm in there. If we're needing to make a price point for something, then he is definitely better. He's also much better in the science, which is quite remarkable. But I think yes, women tend toward collaboration. And some of the breakthroughs we've made in PXE have been because of the women scientists being able to explain to the men that, yeah, you really wish you could get that next paper faster than this, but what about doing this paper together and blah, blah, blah. Still lots of competition, and I get it, the pool is drying up even more than before. But I also think that these kind of dry times bring out a new kind of collaboration where you say, either I go away, even for scientists, I close my lab, or I figure out creative ways to work with disease groups and other entities.
I think what you might consider is that we are really in an era of changing dynamics, in that we're sort of what I call the reversion to the patronage system, and that we have to be more aware of philanthropy, industry interactions, as well as the government, because the NIH budget is not going to go back
Right.
in the next
Foreseeable,
4 years,
yeah.
foreseeable future.
Yeah, great. Thank you so much.
Good.
Thank